Okay. So, fourth degree. When it says fourth degree, not fourth term or four terms, it says fourth degree. What does that mean? Yeah, we want to get to x to the fourth. Okay. So, Taylor polynomial for cos about x equals 0. They were being silly, just called out a Maclaurin. That's what it is. So I'm going to say that cos x is approximately what?
Oh my god, people talking. That's just how it works.
That's a lot of mumbling. I enjoyed that. That's good. Okay, so we have that. This is our Taylor. I'm going to erase that. I'm going to put this as T4. So sometimes they say for a Taylor polynomial, they'll say this is that f of x is approximately this, and this is t sub 4. So the t means Taylor polynomial of fourth degree. Does that make sense? Just some notation for you. Okay. So we're going to go ahead and figure out what that approximation is for 0.8. So if I think about what interval this problem is on, I'm going to say that the interval that it's on is from 0 to 0.8. Why did I say 0? Yeah, it's centered at 0. Okay, so the interval we're on is from 0 to 0.8. That's not the interval for the error bound, but it's going to help us in a little bit. So that's why I'm writing it down. Okay. Yeah, 0 to 0.8. So we're going to, when we do the error later, then yes. So you use the center and the value that you're approximating to come up with your little interval to use for the error later. Okay, so now I'm going to say that f of 0.8 is approximately t sub 4 of 0.8. Those are approximately the same. And that's going to be 1 minus 0.8 to the second divided by 2 factorial plus 0.8 to the fourth divided by 4 factorial. Now sometimes it tells you how many decimal places and sometimes it doesn't. So if it tells you 3, go ahead and do 3. Just know that in the situation where we are doing this on the AP exam, we would probably want to write down as many decimal places as we can because they want the 3 that are right, not the 3 that you use throughout the whole problem, if that makes sense. Okay, so if we were doing this for AP, we would probably write down way more than that. All right, 1 minus... Yeah, rude.
Ready.
There we go. Okay, so I'm going to say that this is approximately 0.697. Okay. So now we deal with the part for the error. We say the error is less than or equal to, and the stuff that we write out has 3 parts. And the first part is the funky one. Anyone remember the first part? It's the next derivative, okay? So this was the 4th power. Technically, since we know that cos does even powers, we could do the 4th, or sorry, we could do the 5th, because 4 plus 1 is 5, or we could do the 6th.
Can we do the 6th?
You guys would rather do that?
Yeah.
Sure, okay. I'm just going to say my answer key is the 5th, but no judgment, okay? So if you compare it later, it will be slightly off, okay? All right, so we'll say f to the 6th of z. I am not putting 0.8 here because I don't know if 0.8 is the part I'm going to use, okay? So this is the part where we say we're going to find the actual 6th derivative, and we are going to look at the graph from 0 to 0.8, and we're going to figure out which value is the largest, okay? So this is the part in the notes where I actually got pictures of the graphs and I looked at them to see which one I should use, okay? So we have that. We have the sixth derivative times, and then what do I have next? X to the sixth over. Okay. So now what I'm going to do is I'm going to think through my derivatives. My original function is cos. My first derivative is negative sine. My second derivative, my third derivative, my fourth derivative, my fifth derivative, my sixth derivative, negative cos. Okay, so you have two options. We can graph it real quick on a calculator, or if you are comfortable picturing a cos graph, then we can think about that in our head. So here's what a negative cos graph would look like. It would start at -1, and it would go up and then come back down. Okay? So cos of 0 is down here at -1. Cos of 0.8 would be somewhere over here. Okay, so which one has a bigger value? Not talking positives or negatives, but which one has a bigger value? The 0, right? And that's because the y value is bigger, even though it's negative, it's a bigger negative. Okay, so we are going to use for f, the sixth derivative, we are going to use the number 1. Not -1 because this is an absolute value. So I just use 1, okay? So I'm going to say my error is less than or equal to 1 times 0.8 to the sixth divided by 6 factorial. Now what I will say is I have been consistent on my answer keys to go through and do this work every time. But in terms of sine problems and cosine problems, it is very common for them to just use a 1 here, since those graphs bounce back and forth between 1 and -1. It's very common for people on a sine or cosine problem to not do that work and just say 1 is as conservative as it could get anyway, so I'm just going to use a 1 and save myself the time. Does that make sense? I did not do that on my answer keys, but that's something that's fair that people do a lot. Okay, so if you want to use a 1 there, it's going to put your decimals off or mine a little bit. Just know you're not wrong. You have a valid argument. Okay, and this is something we start to learn when we get deeper into math, is that there's some things like this where it's almost like preference. I have a good argument for not using 1. If I want to go ahead and use the fifth derivative and say because that's n plus 1 and it fits the formula, and you want to say, yeah, but the exponent of 5 is never there, so 6 makes more sense, we are both right. We both have valid mathematical arguments for doing it the way we want to do it, so our answers will be slightly off, but we are both considered mathematically correct. Okay? Yeah. I have noticed more, these seem to be more as an FRQ, and I think written in such a way that it wouldn't make a difference, but we will do plenty of FRQ practice before we get to our assessment, so we'll get to kind of see how they do it. Yeah. But this is something I emailed the woman who did the AP training this summer for me. I emailed her and just asked about it to clarify before I taught it to you guys, and that's what she said, is like you can do, in this situation, they're okay with the fifth or the sixth derivative, they're okay with both, and they're okay with you doing 1 or with you actually finding the value that would have been less than 1. So they're okay with it both ways. And she's one of the people who actually grades AP exams. Okay, so they're mathematically speaking, both ways are good. Okay. All right, so let's go ahead and type it in and figure out what the error actually is. Yeah, and it gave us, did it give you guys the E thing too? So this is telling me to take my decimal point and move it 4 places to the left. So I have 0.000364. Now in this case, I would not use just 3 decimal places because 0.000 is not beneficial to anyone, right? If we just say it's 0.000. Okay, so I'm going to go ahead and use a couple more. So now it says they want us to come up with this bounds where we come up with an interval that the actual value must be between. So I'm going to say cos of 0.8 should be between 0.697 minus this value and 0.697 plus this value. Okay, So 0.697 minus 0.000, I'm going to say 00036. Are you guys okay with that? And if you want to kind of check these as you go to see if your answers are making sense, you can actually type in COSA 0.8, because we do know how to type that in, and see if the answers are pretty valid. And if you look, this one's pretty good. Yeah. Yeah, that's really accurate. What I noticed, I'm working on the answer key ahead of you guys and making sure that I've done it better than I did last year. And there was one problem. I noticed that the exact answer was not in between my interval, and it was because I used 3 decimal places. If I used 5 decimal places, then it did work. And so, yeah, so sometimes it really comes down to the number of decimals you use. Okay. But yeah, if you're doing it right, it really should work, yes.
For triplets like this, does our calculators need to be in degree or radians?
Radians. Yep, so anything calculus related when we're talking derivatives, the derivative rules we learned are in radians. Okay. Number 2. So 4th degree Maclaurin polynomial for e to the x. So I'm going to say m sub 4 this time since I've got a Maclaurin. Sure. Yeah, the last one said Taylor, which is why I put a T, but we know sometimes they're interchangeable. You know, Taylor centered at 0 is the same thing as Maclaurin. So 1 plus x squared over 2 factorial, x to the 3rd over 3 factorial, x to the 4th over 4 factorial. And they said we're approximating e to the -1. So what are we plugging in? -1, because our function is e to the x. So if we're approximating e to the -1, that means we're plugging in -1. Anyone got it? 0.375. And it was exactly that, right, when you typed it in? Yeah.
This one was a nice one to do back.
Yeah, and so the other thing about it is when I've looked, the FRQ that has to do with this topic is always number 6, which means it's always calculator inactive. Because 1 and 2 are the calculator active ones. So that means the question that goes with this one is always inactive, which means relatively speaking, they have to give you nice numbers to work with. Yeah. So, and we'll see more of that. We will spend some time doing that for Qs. Okay. So if we want to find the error, now they were interesting about this one because based off the information, I would automatically assume that the interval I was looking at was from -1 to 0, because -1 is what I'm plugging in, and 0 is the center. But they gave you this information here. They said find a Lagrange error bound for the maximum error, and that's what we're calculating, right, is the maximum error. when the absolute value of x is less than or equal to 1. They are telling you what interval to use. So when they say this, they're saying your interval is between -1 and +1. Does that make sense? So we are going to come up with an interval based on the information if they don't tell us what they want us to use. So if they didn't tell us, I'd say -1 to 0. But because they told us, this time we're doing -1 to +1. Okay? Does that make sense? All right. So I'm going to go ahead and write down we're finding the error. And that's going to be less than or equal to what? Yeah, the fifth derivative. Okay. And this one, the fifth derivative, is nice. It's just e to the x, right? So this is an exponential function. So I'm going to picture this without, we're going to try as much as we can to not use our calculators for this part, okay? Just because we want to be able to do this by hand eventually. So if I picture an exponential graph, anyone remember what those look like? Yeah, they kind of go up. So an exponential graph goes like this, right? And this e to the 0 is 1, so they usually have a y-intercept of 1 unless there's been another transformation happening to them. So e to the -1 is down here, e to the +1 is up there. So which one has the greater value? E to the +1. So that's what we're going to use. Okay? So I'm going to say the error is less than or equal to e to the +1 times -1 to the 5th over 5 factorial.
So for these, are we looking for y values or the x values?
The y values. So anytime they say, like if they ask you, tell me what the relative minimum is, they're asking for the y coordinate. If they ask you where it's located, that's the x coordinate. So when they say here, find the maximum error, they're talking about the y coordinate that's a result of that. If they ask you where it happens, then you could say it happens at 1. Okay. So let's go ahead and type that in and see what we get. My answer is negative, but I'm not going to write the negative down because I do have absolute value signs around this. Yeah, 0.0227. Yeah.
Why did you put in 1 for u and then -1?
Why did I what? Put a -1 right here?
Yeah.
Because whatever it was you were evaluating, we were plugging in -1 here, we'd plug it in there as well. So just like on this one, we plugged in 0.8.
Yeah. But she's asking why do we have a regular e to the 1? It's not e to the -1.
It's e to the 1 because when we graphed it, e to the 1 was a higher value than e to the -1.
Okay, so those the two x values can be different.
Yes, and that's why this one in the formula says z and doesn't say a or c. Yeah. Because it's some value on the interval. And it could be one of them, it could be the other one, or it could be something in between if there was a little bump up in the middle. Yeah. So this, in my opinion, this part right here is the hardest part to grasp because it's different every time. And sometimes it'll be like the problem we're doing right now where we can find it. And sometimes they'll just tell you, hey, this is the number you should plug in. Yeah. Okay. So we got that. Did we get that decimal okay? We got the negative version, but we're making it positive because absolute value. So now we're going to go ahead and write the interval that we have. So I'm going to say e to the -1 is somewhere in between 0.375 minus 0.0227 and 0.375 plus 0.0227. And when I did this, I did 3 decimal places for this as well, so I had 0.023. So my numbers, so when you check it, if our answers are not identical, just see how many decimals I use, see how many decimals you use. Because it could be we're basically saying the same thing, but our decimals are a little bit off. Okay. So if I do this, when I did it on mine, I got 0.352. So my decimals were a little different than this, and 0.398. And then if we want to check it, we can. So e to the negative 1, 0.367, so that's right in between there. Yeah. Yeah.
Can you explain again why we subtract the 0.0227?
So it's kind of like we're saying this we think is approximately the middle. And so we're saying the error could be that much below the number we're approximating, and it could be that much above the number we're approximating. So that's why we're minusing to find the lower amount, and we're adding to find the upper amount. Okay. All right, and we're gonna write one thing at the top of your page. When I say error, a lot of times, like, I just write it like that. But what I mean by this is that this is f of x, f of whatever the number you're plugging in. So on this one, we were plugging in -1. This is f of x minus p of x, or they can flip them. So in my case, for the one we just did, this would be f of -1, actually e to the -1, subtract off our approximation. So that was the m sub 4 of -1. That's what they mean when they say error. Sometimes they write error. Sometimes they don't write error. They actually write this down. They'll say calculate what this is. They're just asking for the error. And so what they mean by that is how far off is your approximation from the exact value. E to the -1 would be the exact value. What we plugged into the polynomial would be the approximation. Okay, so that's all they mean by that. All right. How are you guys feeling on these ones? You seem like you're handling it okay. All right, so if we look at this one, I'll let you guys do this one on your own. But what they've done here, if you can see this, is they have told you that you don't have enough information to know what the fourth derivative is. You don't get to be the one who looks at the graph and determines which value on the interval you're going to use. They're telling you specifically that 75 is the highest value. So 75 is what you have to use. So these problems are nice because they did the hard part for you. Okay, so from here, they are telling you, though, that it was on the interval from 5 to 5.2. So 5 is the center, 5.2 is what you're going to be approximating, but they've done the work for you of looking at the graph and finding the highest y-coordinate. Okay, so they're just saying somewhere on the interval between 5 and 5.2, there was a y-coordinate of 75, and so 75 is what you're going to use. Okay, so you don't actually have to find it on that one. Make sense? Okay. So go ahead and work on that. I will get the answer keys up as I have them.